First, I decided to make something that looked beautiful, and then figured out how to put a big amplifier in it. And so I started drawing these sketches. Well, once I got the form done, then I had to figure out how to put a lot of stuff into a very small box, because I knew I was going to put a lot of very high-powered output devices in it. And I chose a copper because I wanted to dissipate heat quickly. It moves heat 91% faster than aluminum. So that's a huge factor. Then we had to figure out how we could use the copper, because copper, as you know, tarnishes right away. So we came up with a method. After the copper's treated and machined, it's covered with something very similar to car clear coat, which is very durable, but also a total sealant. So the copper, once it's in that, is kind of hermetically sealed, and it won't ever tarnish. Then getting back to the inside of the amplifier, through-hole components are components you can hold in your hand and you put through a hole on a circuit board and you solder them. So I used to do that 20 years ago. That's how we built everything, and we had the best sounding amps we ever built back then, and the most reliable, and our failure rate was extremely low. But the through-hole parts are more robust, and you use less of them, therefore you're getting less transistor effect when you parallel transistors. So I did that. I had to find a huge power source, so I had a special toroid made that fit in our box that was tailor-made for it. And then, being conscious of noise, it had to be a special kind of toroid, so it was quiet. Then we had I used a special technique in power supplies and the capacitors for a storage bank. And then the wiring and all of the internal parts of the amplifier had to be really meticulously done, and really a lot of thought had to go into how it was actually made, because when you're working in a little tiny hole, which is essentially that, because the amplifier is made of a billet block of aluminum, so it's built from the bottom like a pancake. So you start adding and you start building up, and once you add everything, you have to be conscious of where everything's going and where all the wire routings are, because you don't have room to put anything anywhere. The amplifier became a reality, but it's not that it was easy. It took me almost a year to finish the amplifier, and mostly because of the space. I have to keep on redoing and redoing in order to get the performance window that I wanted. And I don't know, I must have $10,000 worth of old transformers that I can't use, because they're either too small, too big, not enough power, too noisy, on and on. But we have a very exacting goal. So I wanted to make something that was built like a watch inside and out with the meter. I wanted it to have a watch-like quality. So being a watch enthusiast, I decided to make it look a little bit like a Breguet. So the meter wand has a Breguet-styled hand with a hole in the top and a little pointer. And then the gauge itself, if you look at a tourbillon, they have a little bridge, and then you can see the tourbillon movement behind it. So in my meter movement, I have the same bridge, and then I have the meter movement behind the bridge, and then I have a little blind in front of it, just like a watch. And I decided to build it like the watch, but the shape of the gauge is more like a car instrument gauge, like a speedometer, and or a tach, and that's kind of what I wanted too, because when you use power, it's much like using an accelerator. So you can watch the meter move back and forth, and it's causing a sensation of using power. The D'Agostino amplifier itself is a driven, passionate product from me. I mean, I poured my heart into building it. I felt that I hadn't finished contributing to all of the solid-state designs that I had done. And I tried to take some of the things that I have done in the past and melt them into something brand new, something a little bit different than I've done in the past, but not forgetting my roots.